Welcome to lesson 6.5, graphing linear inequalities in two variables. So a linear inequality can be any of these four representations, or typically represented this way, such as ax plus by is less than c, ax plus by is greater than c, ax plus by is less than or equal to c, and ax plus by is greater than or equal to c. So those are our four standard forms for linear inequalities. So example 1 is just simply checking if an ordered pair is a solution of the inequality. So again, keep in mind that every ordered pair is written as x, then y. So our x coordinate's always first, then our y coordinate. So when we are plugging into our inequalities, you want to make sure that the first coordinate replaces x and the second coordinate replaces y. Then we are just going to plug those into the equation and follow the order of operations to check. So in this case, 2x minus 3y is greater than or equal to negative 2. We're going to plug in a 2 for x and a negative 1 for y. So you can see that right here, which gives us 4 plus 3 is greater than or equal to a negative 2, meaning 7 is greater than or equal to negative 2, which is true. 7 is always greater than or equal to negative 2. So if our inequality is true, then the ordered pair is a solution. Looking at the second part, we're checking 0, 1. So plug a 0 in for x and a 1 in for y. And we end up with 0 minus 3 is greater than or equal to a negative 2, which gives us negative 3 greater than or equal to negative 2. This is not true, so 0, 1 is not a solution. So in B and C, we are going to do the same things. Take our x, y, and plug them into the equations and check the inequality. So in this case, negative 3, 5, plugging into 3x plus 5y is less than or equal to 12. So when we plug those in, we end up with a negative 9 plus 25 is less than or equal to 12. Negative 9 plus 25 is 16. 16 is not less than or equal to 12, so negative 3, 5 is not a solution. Then we're checking 6, negative 8, so we plug those in, and we get 18 minus 40 is less than or equal to 12. So then negative 22 is less than or equal to 12, which is true. So 6, negative 8 is a solution. Then with part C, we have 3 times x minus y is greater than 4. Plug in 6, 1. 18 minus 1 is greater than 4. 17 greater than 4 is true, so 6, 1 is a solution. Then plugging in 1, negative 1, end up with 3 plus 1 is greater than 4. Is 4 greater than 4? No, they're equal, so no, 1, negative 1 is not a solution. Now for the graphing piece. What we want to briefly review is anytime x equals a number, such as x equals negative 2 or x equals 7, we end up with a vertical line. Anytime that y equals a number, such as y equals 5 or y equals negative 3, we end up with a horizontal line. Then we also want to keep in mind our steps for graphing inequalities. So the first thing we want to do, if need be, so if it's not the scenario of x equals a number or simply y equals a number, We always want to rearrange the equation to solve for y. In other words, we want to think about slope-intercept form and get it to our form of y equals mx plus b. And remember, in slope-intercept form, m is always the slope, and the plus or minus b part is always our y-intercept. If it's plus, it's a positive. If it's minus, it's a negative. Then step 2 is to graph the line. Now, when graphing inequalities, if it's less than or equal to or greater than or equal to, we use a solid line. If it is simply less than or greater than, we use a dashed line. And then our final step tells us to test a point and shade. And what they mean by that is we will be shading the whole range that could be possible answers. Because if we have an inequality, our answer is not just a line, it is a whole range of values, as you will see. So the way we test it is we plug in a ordered pair, which you will see in the examples below. So example 2 says graph each linear inequality. So what we need to do is the inequalities, when we are going to figure out where to put the line, is we would end up just drawing the line as if it was equal to. Now in this case, you'll see on A, I should have drawn my line as a dashed line. So you'll want to make yours a dashed line, because it is strictly less than. Then we just draw it in as if it was x equals a negative 2, but again, it should be dashed. For testing a point to figure out where we shade, you can choose any point not on the line. If 0, 0 is not on the line, I would always use 0, 0. Now, the way that we test is we take that point and we plug it back into the original. Now, if there is no y value in this case, we just plug in the x coordinate. Is 0 less than a negative 2? No, it is not. So in that case, 0, 0 would not be an answer. That tells me to shade the side opposite of 0, 0. So we're not going to shade toward 0, 0. We would shade the side opposite. So in example B, we have y is less than or equal to 1. So in this case, I have a horizontal line at 1, and it's a solid line because it is less than or equal to. Then I'm going to test to see which way to shade. So again, I'm going to use 0, 0. If I put in 0 for y, is 0 less than or equal to 1? Yes, it is. So that tells me 0, 0 is a good answer. So I'm going to shade toward 0, 0. So all answers toward the side or below our line are possible answers. Now for part C, we want to get our x value alone. So our first thing to do would be to divide by a negative 5. Now remember, when we divide or multiply by a negative, the inequality symbol flips. So for this equation, we end up with x is greater than or equal to 2. So in this case, we draw our vertical line through x is 2, solid line because it can equal. And then we want to check our point. So plugging in 0, 0. Is 0 greater than or equal to 2? No, it is not. So we are going to shade away from 0, 0. So we would shade on this side of our line, meaning anything to the right of our line is an answer. And our last example in this part for horizontal or vertical lines, if we have y plus 8 is greater than 4, we need to solve for y, so we'd subtract 8 from each side and end up with y is greater than negative 4. Again, should be a dashed line here because it's not equal to, so make your line dashed, and it would be at a negative 4. Then we're going to check a point for shading. So I plug in 0, 0. 0 is greater than negative 4 is true. So we will shade toward 0, 0. So we will shade all above our line. Now in example 3, we have to consider putting everything into slope-intercept form. So in example 3, we want to think about y equals mx plus b or slope-intercept form. So again, this is the case where our first thing we'll want to do is if the equation or inequality is not solved for y, we want to solve for y. Our first example A, it is already solved for y. Now, to make sure we use a solid or dashed line, what we should do first is just look at our symbol. If there is the line underneath for equal to, we always know we have a solid line. If there is no line underneath, then we will use a dashed line. So in this case, y is greater than or equal to 2x minus 4. Remember, whatever is attached to x is our slope. So our slope is a positive 2, or 2 over 1. Then whatever is the plus or minus b is our y-intercept. So in this case, our y-intercept is negative 4. So when we draw our line, we start at our y-intercept. So we start at 0, negative 4. Then from that point, we move our slope to figure out the next point in our line. So from 0, negative 4, we would go up to right 1. That would be our next point. And again, we could go up to right 1. That would be the next point on our line. So we draw in our line, and then we still need to check our point. As long as the point's not on the line, we can use 0, 0. So plugging in 0, 0 for x and y, we always plug it back in to the original inequality. So in this case, we end up with 2 times 0 minus 4, so negative 4, and on the left we have 0. So is 0 greater than or equal to a negative 4? Yes, it is. So we want to shade toward 0, 0. In part B, we have x plus y is greater than 3. So first we need to solve for y. So we have to subtract x from each side, and y would equal a negative x plus 3. So our slope is attached to x, which is technically a negative 1. So our slope tells us down 1, right 1. And our y-intercept is a positive 3. So we have to start at 0, 3. So over 0, up 3 is our first point. Then we follow our slope, down 1, right 1, down 1, right 1. And we would draw our dashed line. Then we choose our point to check, which again is 0, 0. Plug it back into the original. So is 0 plus 0 greater than 3? No, it is not. So we would shade away from 0, 0. So anything on this side of our line. Then our last two graphing examples, C and D. Again, in C, because it is greater than or equal to, we'll have a solid line. And we need to solve for y. So our first step is to subtract x from each side. Then we have a negative y is greater than or equal to negative x plus 2. So we need to get our y positive. So we divide everything by a -1. That flips our inequality. So y is less than or equal to x minus 2. So in this case, our slope would be a +1, and our y-intercept is a -2. So to graph our line, start 0, -2, up 1, right 1, up 1, right 1, and we draw our line. Then plugging in 0, 0 to check. It is not a good solution, so we will shade the opposite side of the line from 0, 0. And in D, we have 2x plus 3y is less than 12, so we need to solve for y. So we would start with subtracting the 2x, then divide everything by 3, and we end up with y is less than -2/3 x plus 4. So our y-intercept is 4. Our slope is a -2/3. So then when we're graphing, we start at 0, +4, and our next point would be down 2, right 3, down 2, right 3, and then we draw in our dashed line. Then plugging in 0, 0 to check, we plug it back into the original. 2 times 0 plus 3 times 0 is less than 12. 0 is less than 12, so 0, 0 is a good answer. So we'll shade the side of the line that includes 0, 0. And our final example is a word problem. So it tells us we have some gold and some silver coins in a basket. The gold coins weigh half an ounce each, and the silver coins weigh a quarter ounce. The basket feels no more than 50 pounds. What are the possible amounts of coins? So we know we have 0.5x plus 0.25y coming from the weight of the gold and the silver coins. That is less than or equal to our 50 pounds. But we have different units. So we need to convert our pounds so they are also in ounces. So we would take our 50 pounds times 16 to get 800 ounces. So then our inequality becomes 0.5x plus 0.25y is less than or equal to 800. Then our way to answer this question would be, and I apologize, my graph did not copy over, right? But what you would want to do is you would want to graph this inequality. Or you could plug in for x and y and figure out possible answers. By graphing this inequality, any answer that solves our graph is a possible solution. So what you would want to do to get any possible solution would be to graph this line, and it would include the line itself and anything that was shaded in. So we would have many different possible answers to this question.